Hello everyone, welcome to the next lecture of West Bengal SET exam question practice. Okay, so this is the third session, and in the previous two sessions we already take one session on real analysis, question practice on real analysis, and in the second session we already take question practice session on linear algebra. Okay, so those who are not watching the previous videos, so you can go to the description, you will get a playlist link, WBSET mathematical science. So you can just click this playlist, link of this playlist, and you can get all the videos regarding WBSET exam. Okay, and also the WBSET 2023 previous year papers solutions are also available on that playlist. Okay, so in this session we are going to discuss some questions of ODE or ordinary differential equation. Okay, so let's start, and this is the official WhatsApp group of my channel. So you can just join the WhatsApp group by clicking this barcode or by scanning this barcode, and this is also for CSIR NET GATE so question discussion. So okay, so you can also join the group. Okay, and if you have any query, then you can obviously comment me in the comment section below. So let's start, and before starting I am requesting you to all those who are new in my channel, please give a like to this video, share with your friends, and don't forget to subscribe the channel. Okay, so today's first question. So this is the questions West Bengal PhD previous year question. Okay, so if y1 and y2 are solutions of the initial value problem, y dash plus px, y dash y double dash plus px into y dash plus qx into y equal to 0, if y x0 equal to 0 and y dash x0 equal to 0, and then the Wronskian y w y1 y2 is 0, then y1 1 y2 are. So this is a very easy problem. You all know that if Wronskian of y1 and y2 are not equal to 0, then y1 and y2, that is the solutions y1 and y2 are linearly independent. And number 2 is if w Wronskian of y1 and y2 this is equal to 0, then y1 and y2 are linearly dependent. Okay, so Wronskian is very important. Okay, so obviously you please revise this chapter Wronskian. So here Wronskian 0 means y1 and y2 are linearly dependent. Option A is the correct answer. Go to the next problem. So it says that let A equal to be a given matrix, let xt equal to x1 x2 x3 and mod xt equal to x1 square x2 square and x3 square power half. Then any solution of the first order system of the ordinary differential equation x dash t equal to a xt with x0 x of 0 equal to x0 satisfies. Okay, so see the matrix is given here, the eigenvalues of A. Here we first calculate the eigenvalues of A are what, since this is a upper triangular matrix. Okay, so diagonal entries are the eigenvalue minus 2 and minus 2. Okay, now if the three eigenvalues are same, then how can we write the solution of this system? So we can write xt equal to c1 plus c2t plus c3 t square exponential minus 2t. Okay, now if we choose x1t, this is equal to c1 e to the power minus 2t, x2t this is equal to c1 plus c2t into e to the power minus of 2t, and x3t this is equal to c1 plus c2t plus c3 t square into exponential minus of 2t. Now as t tends to infinity, this tends to 0, as t tends to infinity. Okay, this is again tends to 0 because exponential power is in negative power as t tends to infinity, because we have to find this mod of xt as t tends to infinity. Okay, because here four options are mod of xt and limit. So and again this is also tends to 0 as t tends to infinity. That means all the x1 x2 and x3 are tends to 0 as t tends to infinity. That means limit and mod xt value is this power half. So that is limit t tends to infinity mod of xt, this is equal to clearly 0. Okay, so option A is the answer of this problem. Okay, next question. So the positive values of lambda for which the equation y double dash plus lambda square into yx is equal to 0 has non-trivial solution satisfying y0 equal to y pi and y double dash y dash 0 equal to y dash pi. So see here I can give you and shortcut tips. So the shortcut tips, without solving this problem you can easily solve this types of problem. Okay, so consider the problem y double dash plus lambda y, this is equal to 0. Okay, and ya equal to suppose yb and y dash a equal to y dash b, that is periodic boundary condition, periodic type of boundary conditions. Then how can we directly find lambda? So lambda equal to, here the formula is 2n pi by l whole square, where l equal to the length of the interval, that is b minus a. Okay, so here the interval is 0 to pi. Okay, so here because here it is given y0 and y pi. Okay, so a equal to here 0 and b equal to simply pi. Okay, that is l equal to simply pi minus 0, this is equal to pi. So lambda equal to here, so here it is lambda square. Okay, now we must find in case of this problem, so that is you can put the value here lambda square, because this is given lambda square. In general this is lambda. Okay, so lambda square equal to 2n pi by l means pi whole square. Okay, so this is equal to 2n whole square, that is simply you can write lambda equal to 2n. Okay, now here if the in the question it is given y double dash x plus what lambda y, this is equal to 0, then the value of lambda should be what, 2n pi by pi whole square, that is here 4n square, but here lambda square is given, so that's why we can put here directly lambda square. Okay, so this is the general problem, you just remember this thing and you can get these types of question you can easily solve in the exam with the fractions of seconds. Okay, now next problem, consider the initial value problem, IVP equal to dy dx equal to y square, y0 equal to 1, xy belongs to r cross r, then there exists unique solution of the IVP. So you have to find the interval. Okay, in which the IVP has unique solution. Okay, fine. So you can easily solve these types of problem, and this types of problem is known as Picard's. You can easily solve by using Picard's theorem. Okay, so here it is given dy dx is equal to y square. Okay, now we all know that the interval like this, x minus x naught, x minus x naught less than a and y minus y naught less than b, and here it is given the question exam is y of x naught equal to y naught, so that is here x naught equal to 0 and y naught equal to 1. Okay, so we can write this is mod of x minus 0, this is less than a, and what mod of y minus 1 is less than b. Now we defined an h. Okay, so h equal to what, h equal to minimum of a comma b by m, while m is equal to maximum of f of xy mod of f of xy, and the value of mod f of xy is this one, this is the value of f of xy. Okay, so this is maximum of f of xy, that is f of xy means here only y square. Okay, now here it is given that mod of y minus 1 is less than b, that is from here we can write minus b less equal or less than, simply less than, minus b less than y minus 1 is less than b, that is we can add both side plus 1 minus b less than y less than b plus 1, that is the maximum value of y occur at the point b plus 1, so this is equal to simply b plus 1 whole square. Okay, now we can find the value of x. Okay, h. Okay, so h equal to what, h equal to minimum of a comma b by b plus 1 whole square. Now we can easily find the value of this minimum by taking phi of b equal to b by b plus 1 whole square and this phi dash equal to b, and you can find the value of b. This is one way, but here you can simply observe that. How can you observe here that this b by, just a second, this b by b plus 1 whole square, this value is always less than 1. Now the value of a, okay, the value of a should be like, so this is like minimum of, you can calculate by this, but how can you calculate without this skipping this calculation? Okay, so a and this value is obviously less than 1, so minimum of a and a less than 1, like this is always less than 1. Okay, so that is the value, that is the solution exists in this mod x is less than what? No. Sorry. This is less than 1. That is h, the value of h should be here. I think it should be h. Mod of x, it should be h. I think h. No, this is a. So the value of h should be what? In less than 1. Okay. In less than 1, in this interval, the value occur. Okay. That means here minus 1 less than 1. That is, we can write mod x is less than 1. That is, x belongs to minus 1 1. I think minus 1 1, and the options are minus 1 infinity. No. Mod x not less than 1. This is in the interval less than 1. You can just calculate by this way. Okay, I just give you a shortcut tip. So it is less than 1. So the minimum of a and less than 1 is always less than 1, because the value of a should be obviously greater than 0. Okay, so that is the correct interval. You can observe from this 4 option is option B, because less than 1 is only given in this interval. This is less than 1. No, this is less than 1. No, because more than 1 here in this interval, 1 से ज़्यादा जो portions है वो भी included, but here also it is not given. Okay, so this is the smallest or shortcut tips. You can also, अब मैं और एक बार बोल देता हूँ कि आप इस जो यहाँ पर जो प्रॉपर मेथड है वहाँ पर जाकर आप सॉल्व कर सकते हो इस प्रॉब्लम को इजीली. ओके, सो नेक्स्ट प्रॉब्लम. सी, this problem is says that the initial value problem y dash equal to 2 root y, y0 equal to a hatch. Okay, so this is very easy types of problem if you know the shortcut tips. So what is the shortcut tips? What is the shortcut tips? So we know if dy dx equal to, suppose k into y to the power alpha. Okay, and k obviously all time greater than 0 hoga. Okay, now if with y of b equal to 0, where b belongs to r. Okay, so if this happens and if alpha belongs to 0 1, then this gives always infinite solution. Okay, so and one more thing is also notice that y of b0, here it is b equal to what? 0. So y of b equal to 0. If we compare this equation, this is a. Now if a equal to 0 and here y power of y is half, and half we all know that this belongs to interval 0 and 1. That is, if we compare this with these shortcut tips or with these tricks, then we see that if a equal to 0, then this gives infinite solution. Okay, so here you can easily find that if a equal to 0, then this is infinitely many solution. Okay, and one more thing I also say you that if here a is greater than 0, okay, these types of problem, in these types of problem, if a is greater than 0, then we get infinite solution. So you can remember this thing. Okay, sorry, no infinite solution, it is unique solution. Okay, it is unique solution. So unique solution for a greater than 0, and here it is option B. It says that no solution for a greater than, no. Unique solution for a less than 0, no. Unique solution for a greater equal to 0, but this is not greater equal to sign. Unique solution only for a is strictly greater than 0. That's why this is also not correct. Okay, now next problem. This problem says that let yx be a continuous solution of the initial value problem y dash plus 2y is equal to fx, y0 equal to 0, where fx equal to this one, then the value of y 3/2 is equal to. Okay, fine. How can we find the solution? So it is given that y dash plus 2y, this is equal to fx. Now we proceed to solve this problem. So if, that is the integrating factor, this is equal to integration e to the power 2 dx, that is e to the power 2x. It is okay. Now we can write the solution. So integration d of y e to the power x e to the power 2x, this is equal to integration fx into e to the power 2x into dx. Okay, fine. So this is equal to integration d of this, means integration simply we can write y e to the power 2x. This is equal to the value of fx in the interval 0 and 1. It is 1 and otherwise 0. So we can just write integration 0 and 1. Fx means 1 into e to the power 2x into dx. Okay. So this is e to the power 2x by 2, and if we integrate, then this we get e to the power 2 by 2. Okay, sorry, e to the power 2 minus 1, square minus 1, because at the point 0 it gives minus 1. Okay, Now if we put x equal to 3 by 2 both side, okay, so y into e to the power 2 into x, that is 3 by 2 into 2, that is it is eq simply, and this gives simply e square minus 1 by 2. Okay, so y equal to 1 by 2 e to the power 3 into e square minus 1. Okay, so this is equal to 1 by 2 into 1 by 2 e, I think, sorry, 1 by 2 e square, 1 by 2 e square into e minus e inverse we can write, and we know that e minus e inverse or e to the power x minus e to the power minus x by 2, this is equal to what? Sine hyperbolic x. Okay, fine. So it is x equal to 1, so that means 1 by e square into sine hyperbolic point is 1 here. So which option is correct? Option I think which option is correct? So I think here it is mistake in the option. So in this option, like sine hyperbolic 1 by e square, this will be the correct answer. Okay, option, I think there mistake, it has mistake in the options. Okay, so now next question. The next question, it says that consider a second order ODE x double dot plus pt into x dot plus qt into x, this is equal to 0, and let x1 x2 be two solutions of this ODE in the interval AB, then which of the WOTF means which of the following options are true, options are true or is true. Okay, for the Wronskian x1 and x2. So it says that option A, Wronskian is identical to 0 in AB implies x1 x2 are independent. No, we all know that Wronskian 0 means they are dependent. We can change the sign in Wronskian in AB. No, we also, this is also an important tips, that Wronskian is same throughout the interval. Okay, it is not change its signs in any interval. Suppose W belongs to this interval, then W maintains its same sign in this interval. Okay, so W cannot change its sign. Then option C says that W T0 equal to 0 for some T0 belongs to AB, then W is identical to T0. Yes, if for any point in between this interval it gives a simple 0 value, then throughout the interval it gives the 0 value. It is directly result. Option C is true. If W T0 equal to 1 for some T0 belongs to AB, then this is equal to 1. No, it may not be true, because it is only true for it is 0 for any point belongs to any interval, then it is throughout the interval 0. Okay, or you can also check this option by construct any interval. Okay, so this is not the big fact like this. Okay, now the next problem. If y dash equal to yx is a solution of the equation 4x y double dash plus 2y dash plus y equal to 0, satisfying y0 equal to 1, then y dash 0. So you can solve this problem by applying the particular or the correct method, but here I am not applying any method. So see the solution or the way of the solution I can do here. Okay, see, it is given that 4x y double dash plus 2y dash plus y, this is equal to 0. Okay, fine. So and it is given y at 0 equal to 1. Now I put here x equal to 0 in this equation. So this gives, this is present. So 4 into 0 into y double dash at the point 0 plus 2y dash at the point 0 plus y at 0, this is equal to 0. So this gives completely 0. So 2y dash 0 plus y0 value is present. So y0 means plus 1, this is equal to 0. That is y dash 0. So this is equal to minus 1 by 2. Okay, now if we differentiate this with respect to x, then we get 4x y triple dash, okay, plus 4y double dash. Y double dash means y double dash x, obviously it is a function of x. Okay, plus 2y double dash x plus y double dash x, this is equal to 0. Now if we put again x equal to 0 in this equation, then this is completely 0 plus 4y double dash 0 plus 2y double dash 0 plus y dash 0, this is equal to 0. So this gives total 6y double dash 0 plus the value of y dash 0 should be minus of half, we can put here. So this implies y double dash 0 equal to 1 by 12. So see, this is the easiest way to solve this problem without solving this differential equation. Okay, so option B is the correct one. Next problem. It is given that let y1 and y2 be two linearly independent solutions of y double dash plus sin x into y is equal to 0, 0 less x less equal to 1, gx equal to Wronskian of y1 and y2 at x with the Wronskian of y1 and y2, then what is the value of g? Okay, fine. So see, the differential equation is y double dash plus 0 into y dash plus sin x into y. This is equal to 0. And if we apply the Abel's formula, then what is the Wronskian? Wronskian equal to, you all know that w of x, that is w of the function y1 and y2. This is equal to y naught, y at 0 or y at x not equal to 0, y not equal to 0 or w0. We can just reply this is the initial value. Okay, and e to the power minus of the coefficient of y dash by coefficient by y, that is 0 by 1 into dx. Okay, so this is equal to w0 e to the power 0 means simply w0 e to the power 0 means 1. Okay, so it is obviously a constant value. Okay, this is obviously a constant value, you all know that, because this is the initial value. Okay, fine. So this is the value of g. So gx, this is equal to Wronskian of x. Okay, fine. So what is the value of gx? And this is equal to simply a constant. Okay, so what is the value of gx? G dash x. So g dash x is completely 0. Okay, so it option A says that g dash is greater than 0, no. Less than 0, no. Vanish only 1 point, no. This is value for all x belongs to the interval 0 and 1. So this is also not correct. G dash vanish throughout because this is identical 0. Okay, so this is the correct answer of this problem. Now the next problem, consider the ODE. What is given? Y dash x equal to f of yx. Okay, f of yx, y dash x equal to y of x. That is, we can conclude here that yx is a solution. Yx is also a solution, and it is given f is an even function, that is f of minus suppose u, this is equal to f of u, f is even, and y is an odd function, that is y of minus of v, suppose this is gives minus y of v. Okay, now then since yx is a solution, now if we see that this is a solution or not, so minus of y of minus x, since y minus x, y is an odd function, so we can write y of minus x, this is equal to minus of yx. So this is clearly again yx, so this is equal to yx, and yx is a solution, that means clearly this is a solution. Okay, so we cannot proceed the further options, or you can also see if yx is a solution but y of minus x, this is equal to minus of yx. Okay, if yx is a solution, then minus of yx may or may not be solution. Okay, so we cannot say anything about this, so this is incorrect. Similarly also this is incorrect because this is the form of this. Okay, simplest form, and yx into y minus x, we cannot say about anything. Okay, so option A is clearly true here. So these are the questions. It's a very short lecture of 10 questions of ordinary differential equation. So this is short lecture because I make already 2 videos, one of 56 minutes. I think the real analysis is of 56 minutes and the linear algebra is of 48 minutes. But I think you are not watching the lengthy videos or longer videos. I don't know why. So please watch this video very carefully, and it is obviously helpful for you for your preparation. Okay, so please comment me once if you need longer video or shorter video. So it is a very short video, so with 10 questions of ordinary differential equation. So if you are interested to solve like this the question series for WBSET exam, then don't forget to comment below. Okay, don't forget to comment below whether it is good for your preparation or not. Then obviously continue this series, question practice series. Otherwise we have to think. Okay, so thank you for watching. Bye.